Hello class, today I'm going to be reading Oh No, Hydrogen Cyanide Got in My Eyes. So it's about a mystical story about a bacteria who has immense impact on a certain pathway. Just remember kids, just wash your hands and do not ingest hydrogen cyanide. It may be yummy, but eat Koreans instead. Hi, my name is Pseudomonas aeruginosa, a super crazy gram-negative bacterial cell. I cause keratitis and eye disease, specifically in the cornea, and I cause irritation, damage to the optic nerve, retina, and blindness. My friends like fungi and injury also have this disease, but I'm more important. Pseudomonas is the name. I also secrete extracellular toxins that include proteolytic enzymes, phospholipase, enterotoxins, cytotoxic factors, and my favorite, hydrogen cyanide. I love hydrogen cyanide due to its disrupting of metabolic pathways needed for function. Every cell in the human body needs glucose for energy, but when I secrete this molecule, something crazy happens. Beware. So this is the ETC and ATP synthase. And before I explain my master plan, let's see what I disrupt first. So how does this little fancy system work? Well, there are 4 membrane-bound enzymes named NADH reductase, succinate dehydrogenase, cytochrome oxidoreductase, and cytochrome C oxidase. There are also enzymes that move freely, like ubiquinone and cytochrome C. ETC runs off a H+ proton gradients due to NADH helping carry an H+. The free-moving complexes help pass electrons to the complexes, and H+ protons then go to the ATP synthase to produce ATP. Complexes 1, 3, and 4 main job is to pump protons into intermembrane space. Complex 2 promotes proton pumping into 3 and 4. That's a lot of info, but let's go deeper. So this is more information about each types of the complexes, but we're going to focus on complex 4. Complex 4 has 4 electrons that are used to convert a molecule of oxygen to 2 molecules of water. Oxygen is the final electron acceptor, and it contains 2 heme groups, 3 copper groups, and an iron heme. And it also talks about CoQ and site C. Enough of this silly talk, let's talk about the madness. Disruption of cytochrome oxidase, which is complex 4. Since complex 4 involves the last electron acceptor, what would happen if I disrupt it? My master plan is hydrogen cyanide acts as a cellular asphyxate, which is a harmful vapor. As this molecule binds to complex 4, preventing the use of oxygen in metabolism, this happens when hydrogen cyanide combines with Fe3+ ion in the complex 4 heme A3. As this heme is no longer recognizable for oxidation, the oxygen can't be used as a final electron acceptor. The unuse of O2 then puts emphasis on anaerobic glycolysis, producing a severe acid-base imbalance in the cell. ATP production eventually comes to a halt. Overall, ETC would stop and the gradient of H+ would decrease. I have been irreversibly inhibited. And then this is a picture of before of heme A3, and then after how cyanide binds. So cyanide prevents the oxygen metabolism of CuB copper and can no longer reduce O2 to water, phase. So the body also finds ways to excrete this toxin to prevent further complications. So hydrogen cyanide can be metabolized by an important enzyme, rhodinase, and is used for detoxification of sulfur and an anti-oxidative in stress system. This enzyme carries sulfur atoms by forming persulfide intermediates. Rhodinase catalyzes sulfur from thiosulfate to cyanide to non-toxic thiocyanate. Thiocyanate can be excreted through urine, but only small amounts of cyanide only. And then this is the kind of like the chemical equation where cyanide goes in and then rhodinase catalyzes it and goes to the urine. Bye-bye cyanide. These humans can also try something else too, the use of antibiotics to kill bacteria like me. And that's the type of antibiotic, and you can use antibiotic eye drops, and the cornea infection is no longer there. So why does all this hydrogen cyanide talk matter? The electron transport chain is the main source of ATP production. It produces 20 ATP, 36 total, and with no ATC, then no ATP, which means no life. And warning, you can be exposed to hydrogen cyanide in other ways, such as domestic fires, vehicle exhaust, and cigarettes, so don't smoke. Hydrogen cyanide is bad. In this little background information, hydrogen cyanide was discovered in 1782 by Carl Wilhelm Scheele, in the electron transport chain in 1961 by Albert Linder. The end. And acknowledgements, thank you to Dr. Aaron Weber for your input and ideas. Also, thank you to all the sources I used to get this info. Thank you.